Hi folks, and welcome back to Math with Captain Rod. I'm making this video here to provide examples of how to apply the even-odd test, or how to test a function for even and oddness. And just as a quick little reminder over here, when a function is even, that it means it has y-axis symmetry here, or it's symmetric about the y-axis. If a function is odd, that means it's symmetric about the origin, or I put OS here for origin symmetry. So what we're going to do is we're going to walk through this example, testing each of these functions for even versus oddness. I'm going to take them and move them over here a little bit first. All right, let's start with h of x. So the test for symmetry is this. You look at h of minus x. Right? If you get the same function back out again, then the function is even. Right? So if h of minus x is equal to h of x, then the function is even. If it's equal to minus h of x, the function is odd. And if it's neither of these, then it's neither. All right, so here's what the test looks like. Get this out of the way. All right, so we're going to take a look at h of minus x. So we're putting minus x in for x. Now, when we take this minus x and the square applies to both of them, negative 1 squared is 1, so this is just x squared plus 1. And this is equal to h of x. So this function is even, or I like to say even Steven. And it's therefore symmetric about the y-axis. All right, let's test this one. Let's move this up a little. All right, let's have a look-see. So we're going to take a look at g of minus x. That's going to read 2 times minus x to the 5th minus 10. All right, now this minus sign to the 5th power is still negative, so this is equal to negative 2 times x to the 5th minus 10. This is not equal to g of x, right? G of x is the positive 2x to the 5th minus 10. This is minus 2x to the 5th minus 10. It's also not equal to minus g of x. If this is g of x, minus g of x would be minus 2x to the 5th plus 10. So this function is neither even or odd. All right, let's take a look at this one. Let's take a look at z of minus 1. I'm sorry, minus x. We're going to put a minus x here. And then that is cubed over minus x in the bottom squared plus 1. Now we'll simplify a little bit, so negative 1 being cubed, that's still negative 1. So that top is going to end up being minus x cubed. And the bottom, negative 1 squared, is positive 1. So that bottom is x squared plus 1. Now you'll notice that this minus sign, if I kind of factor it out, we get this. And this thing in parentheses is our original function. So this is equal to minus z of x. I might have said g of x earlier, I'm sorry, but z of x. So this is equal to minus z of x. So this function is odd, or I always say like odd rod. And therefore it is symmetric about the origin. So the purpose of this video was to provide examples of how to apply the even-odd test. Have a great day.